Hello everybody. Welcome to the first part of a survey on trigonometric functions. It has a form of questions and answers.
What are trigonometric functions?
Well, one can define sine, cosine and the other four by means of a right-angled triangle. Let C be the hypotenuse, let A and B be the other two sides of such a triangle, and let alpha be the angle between B and C. Then sine, cosine and the others of the angle alpha are defined as the 6 possible ratios of the side lengths. The sine of alpha is A over C, the cosine is B over C, the cosecant is C over A, the secant is C over B, and the tangent is A over B, and finally the cotangent is B over A. Another way to define sine and cosine is by means of the unit circle. It is a little more appropriate for our purposes, since we want them to be defined for any real number, not just for angles between 0 and 90 degrees. Assume the red point is moving on a unit circle counterclockwise, starting at the very right. In each position, x would denote the length of the path traveled so far. This path is shown as a red curve. Then cosine of x and sine of x denote the x-coordinate and the y-coordinate of that point. Since we start at position 1, 0, at the very right, is shown here, we know that cosine of 0 must be 1 and sine of 0 must be 0. As the point moves around the circle, sine of x increases and cosine of x decreases until in the position where x is a fourth of the circumference of the circle, x equals pi over 2, the cosine of pi over 2 equals 0 and the sine of pi over 2 equals 1. If we continue as shown here, the sine decreases and the cosine even gets negative, and so on. The sine and cosine of negative numbers, or of numbers larger than the circle circumference 2 pi, can also be defined. We just move backward, clockwise, or we move several times around the circle. The graphs of the sine and the cosine function look as follows. By the way, the relation between the angles alpha and the radians x is an easy one. They are proportional to each other with a conversion convention that 90 degrees is equivalent to pi over 2 in radians. In calculus we don't use angles, just radians.
The sine seems to be more popular than the secant, right?
Well, yes, I only described sine and cosine on the unit circle. The other four could also be described this way, but each one of them can be expressed by sine and cosine. So it is maybe even more convenient to just remember how they depend on sine and cosine. We have tangent of x equals sine of x divided by cosine of x, cosecant of x equals 1 over sine of x, secant of x equals 1 over cosine of x, and cotangent of x equals 1 over tangent of x, which is equal to cosine of x divided by sine of x. So really, forget about secant and cotangent and what was the other one again? Cosecant, maybe even about tangent. Actually, we wouldn't even need the cosine, since shifting the graph of the sine by pi over 2 to the left, we get the cosine. Therefore, the cosine of x equals the sine of x plus pi over 2.
Some say that trigonometric functions are periodic.
Oh yes, a function is periodic if its graph repeats itself over and over when moving to the right or to the left. A function f is periodic with period p if f of x plus p equals f of x for every x. That means that all we need to know is f of x for the x between 0 and p. All other values follow. Trigonometric functions are periodic with period 2 pi.
What are trigonometric identities?
The most important one is sine of x squared plus cosine of x squared equals 1. It follows from the theorem of Pythagoras in the definition of sine and cosine, either in the triangle or on the unit circle. For the right-angled triangle, since sine of alpha equals a over c and cosine of alpha equals b over c, we get sine of alpha squared plus cosine of alpha squared equals a over c squared plus b over c squared, which is a squared plus b squared over c squared. And this is equal to 1, since a squared plus b squared equals c squared for right-angled triangles. For the definition on the unit circle, note that there is a right-angled triangle with sides sine of x, cosine of x and 1. Of course, this identity could also be reformulated as in sine of x equals plus minus square root of 1 minus cosine squared, or cosine of x equals plus minus square root of 1 minus sine of x squared. Then there are also formulas for sines and cosines of sums and differences. So let me just show this. There are also formulas for the double angle that follow easily from the sum formulas by using x equals y. The sine of 2x equals 2 times sine of x times cosine of x, and the cosine of 2x equals cosine of x squared minus sine of x squared. Let me also briefly show formulas for products of sines and cosines. But actually there are many more identities.
Do I need to memorize all trigonometric identities?
No, you don't. I'm fine if you just remember sine of x squared plus cosine of x squared equals 1. And remember that there are formulas for sines and cosines of sums and differences, and also for sines and cosines of double angles. And in particular, if you remember where to find them.
What are inverse trigonometric functions?
These are the inverse functions of trigonometric functions. The inverse of sine is called arcsine or sine inverse. The inverse of cosine is called arccosine or cosine inverse. The inverse of tangent is called arctangent or tangent inverse.
But how could that be? Trigonometric functions are not one-to-one.
Yes, you're absolutely right, they are not. But we can force them to be one-to-one by restricting the domains. Sine of x and tangent of x, for instance, are one-to-one for x between negative pi over 2 and pi over 2, whereas a cosine is one-to-one for x between 0 and pi. So we restrict the domains of the trigonometric functions to these domains and get one-to-one functions that have inverses. And yes, of course, there's something arbitrary here. We could have selected different domains and would have gotten different inverse functions. The domains chosen are just convention.
But isn't the secant 1 over cosine?
Yes, but secant of x defined by 1 over cosine of x is not the same as the inverse of the cosine, arccosine, or cosine inverse. Remember that the superscript of -1 for functions has nothing to do with 1 over. It is just an abbreviation for the inverse functions. Only for expressions like cosine of x, the superscript of -1 means 1 over. Thus, the cosine of x to the power of -1 would be 1 over cosine of x, but cosine inverse of x is not. Alright, thanks for listening. In the second part I will discuss trigonometric functions in calculus, their derivatives and their integrals.